Today the topic of our discussion is isotopes. The term isotope is formed from the Greek roots isos, equal, and topes, place. So the meaning of the isotope is the same place. The definition of isotopes. Isotopes are atoms of the same element which contains the same number of protons but different number of neutrons. They have the same protons but they have different neutrons. For example, there is an element hydrogen and it has three isotopes: hydrogen 1, hydrogen 2, hydrogen 3. Hydrogen 1 is called protium, hydrogen 2 is called deuterium, hydrogen 3 is called tritium. Atomic mass of this hydrogen is 1 and atomic number is also 1. Atomic mass of this hydrogen is 2 and atomic number is 1. Atomic mass of this hydrogen is 3 and atomic number is 1. It means that these three isotopes of hydrogen are showing the same atomic number, that is 1, 1, 1. As you know, that atomic number is the number of protons and number of electrons. So the definition shows us that atoms of an element having the same number of protons but they have the different number of neutrons. Here the protons are shown with the blue circle, neutrons are shown with the red circle, electrons are shown with the green circle. If we see this hydrogen atom, it has only one proton and there is no neutron inside the nucleus of this hydrogen. So when the number of protons are 1, so the number of electrons are also 1. And you know the definition of the atomic number. Atomic number is the number of protons and number of electrons in an atom. And the definition of the mass number is number of protons plus number of neutrons inside the atom, inside the nucleus of an atom. So here we have the atomic number 1 because there is only one proton in the nucleus of this hydrogen. Now come towards the hydrogen 2. Here we can see that inside the nucleus there is one proton and one neutron. So the mass number of an element is the total number of protons plus neutrons. So we can say the mass of this hydrogen is 2 because there is one neutron and one proton. So the atomic mass of this hydrogen is 2 because one neutron and one proton. That's why this hydrogen is called a hydrogen 2, or we can say deuterium. Now come towards this hydrogen. This hydrogen is having only one proton and there are two neutrons. You can see in this diagram that there are two neutrons are present inside the nucleus of an atom and there is only one proton. So total number of protons plus neutrons is called the atomic mass. So the atomic mass of this hydrogen is 3. So this is clearly shown in the figure that the atomic number is 1 because they all have the same number of proton, that is 1, 1, 1. But they have the different number of neutrons. Here the neutron is 0, here the neutron is 1, here the neutrons are 2. So how can we find out the number of neutrons? Atomic mass minus atomic number. If we are going to find out the number of neutrons of this hydrogen 1, so we will write 1 minus 1. This one is the atomic mass, this one is the atomic number. 1 minus 1 is equal to 0. So the figure also shows you that there is a 0 neutron in this hydrogen. Now come towards the hydrogen 2. How can we find out the number of neutrons of this hydrogen 2? Atomic mass minus atomic number. So the number of neutrons of this hydrogen is only 1. So we can see here that there is only one neutron. Now, how can we find the number of neutrons of this hydrogen? Atomic mass minus atomic number. Atomic mass is 3, atomic number is 1. So 3 minus 1 is equal to 2. So there are 2 neutrons in this hydrogen atom. So the definition clearly shows us that the number of protons are same but the number of neutrons are different. Or in other words, we can say that isotopes are atoms of an element which have the same atomic number but the different mass number. Now consider another example, that is carbon. Carbon is an element which is present in groups 4a in the periodic table and the atomic number of carbon is 6. Now this carbon is having the 3 isotopes in nature: carbon 12, carbon 13, carbon 14. Number of protons are shown with the orange balls and number of neutrons are shown with the blue. Now we will see that how many number of protons in this carbon: 1, 2, 3, 4, 5, 6. How many number of neutrons in this carbon? 1, 2, 3, 4, 5, 6. So the number of protons are 6 and the number of neutrons are also 6. So what is the mass of this carbon? 6 plus 6 is equal to 12. Now come towards this carbon 13. Here the number of protons are 1, 2, 3, 4, 5, 6. And the number of neutrons are 1, 2, 3, 4, 5, 6, 7. Now you see, in this carbon there were 6 neutrons and in this carbon there are 7 neutrons. So we can say that if the number of neutrons is 7 and number of protons is 6, so 6 plus 7 is equal to 13. That's why this carbon is having the atomic mass 13. Now come towards another carbon. This carbon have how many protons? 1, 2, 3, 4, 5, 6. And how many neutrons? 1, 2, 3, 4, 5, 6, 7, 8. So there are 6 protons and 8 neutrons. So the total mass of this carbon is 14. So see that number of protons are same, that is 6, 6, 6. So their atomic numbers are also the same, that is 6, 6, 6. And their neutrons are different, 6, 7, 8. So their atomic masses are also now different, that is atomic number is 6, atomic mass is 12. Atomic number is 6, atomic mass is 13. Atomic number is 6 and atomic mass is 14. So the number of electrons is the same as the number of protons inside the nucleus. So how can we calculate the number of neutrons of this carbon? Again the same method, that is number of neutrons is equal to atomic mass minus atomic number. Take another example of chlorine. What are the isotopes of chlorine? There are 2 isotopes of chlorine, chlorine 35 and chlorine 37. Atomic number is same, that is 17. Both have the atomic number 17. Why? Because the number of protons are the same, that is 17 protons, but they differ in their number of neutrons. Chlorine 35 has 18 neutrons and chlorine 37 is also having 20 neutrons. So they differ in their number of neutrons. That's why their masses are different. 17 plus 18, 35. 17 plus 20, 37. So the number of the electrons are the same as the protons. Here you can see the diagram that inside the nucleus there are total 17 protons. Red sign, red balls indicates you the proton number and green sign shows you the neutron number. So the electrons are the same as the number of protons. About 75% of naturally occurring chlorine is chlorine 35 and only 25% is chlorine 37 in nature. So the definition tells us that isotopes are the atoms of an element which have the same number of protons but they have the different number of neutrons, and you can see over here that number of neutrons are 18 in chlorine 35 and number of neutrons are 20 in chlorine 37. So this is another example of isotopes of chlorine. Isotopes of uranium. Uranium is another element, but this uranium is radioactive in nature. In nature, uranium is found as uranium-238, uranium-235 and uranium-234. Uranium-234, uranium-235, uranium-238. They have the same atomic numbers, 92, 92, 92, but they have the different atomic masses, that is 234, 235 and 238. So if we see the abundance of these isotopes, so uranium-234 occur in nature in 0.0055% only. Uranium-235 occurs in nature in percentage 0.720%, and uranium-238 occurs in nature in about 99.2745%. So this uranium-238 is the uranium having the highest percentage in nature. So these all three are the isotopes of uranium, and these three are the radioactive. Radioactive means that they are not stable. Their nuclei are not stable. They can emit radiations. So isotopes have the same chemical properties, but they're slightly different. They have the slightly different physical properties. What does it mean that they have the same chemical properties? Because they have the same atomic numbers. They have the same protons numbers. But they have slightly different physical properties means that their masses are different. Their atomic masses are different. If atomic masses are different, then physical properties also vary. Because physical properties depends upon the mass of an element. What are the physical properties? For example, boiling point, melting point. So they depend on the mass number. Carbon 12, carbon 13, carbon 14. Now the masses are different. Carbon 12, atomic mass is 12. Carbon 13, atomic mass is 13. But carbon 14 is having atomic mass 14. So the massive element is the carbon 14. But they have the same chemical properties. Whenever they take part in a chemical reaction, they always shows the same character, they always show the same properties. Whenever they are taking part in the chemical reaction, they always act in a similar way. They always react in a similar way as carbon 14 is going to take part in a chemical reaction, whether carbon 13 is going to take part in a chemical reaction, or carbon 12 is going to take part in a chemical reaction. So they always react in a similar way because they have the same atomic number, they have the same number of electrons, they have the same number of protons, but they differ in their physical properties. Thank you.